converse of midpoint theorem. So midpoint theorem. What does midpoint theorem means? It means if we are given a triangle, any type of triangle, okay, we are taking midpoint of two sides. Midpoint of two sides. So we are given midpoints of two sides, and when we join them, that time this line we have to prove it is parallel to the third one. This is the midpoint theorem. In this case, we are given midpoint of two sides. Suppose it is A, B, C, D, E. Okay, so we are given D is midpoint of AB and E is midpoint of AC. Okay, so this is given. That means midpoint of two sides, this is given. But we have to prove that DE parallel BC. Okay, this is the midpoint theorem. Now we are talking about the converse of midpoint theorem. Converse means opposite. Okay. In this case, we are given a triangle, but one midpoint is given, another not given, one midpoint given, and one more thing is given, that is that when we draw a line parallel to the third side, one midpoint given and we are drawing a line through this point parallel to the third side, this side. Okay, now we have to prove that this is also the midpoint. Now only one midpoint given and we have to prove this one also the midpoint of the side AC. Okay, we are taking DE. So in this case, given D is midpoint of side AB. Okay, and one more thing given, DE parallel BC. So we have to prove that AE equal to EC. That means we have to prove that E also midpoint of AC. This we have to prove. Okay, another way, any way we can write. This also we can write. It also means that E is at the center of the line AC. Okay, so this is we have to prove. So this is called converse of midpoint theorem. Okay, converse, opposite. In this case we have to prove parallel. In this case parallels are given, we have to prove both are the midpoint. Means one is given, another also the midpoint. Okay, so how to prove? We will construct a line here from C, and this is parallel to the BA, this line. Okay, we are taking a line which is parallel to this line. Okay, so draw it further. Okay, this is the point. Suppose this is the point M. Okay, so here we will prove these two triangles which are formed, they are congruent. If we prove these are congruent, then we can prove that AE equal to EC. Okay, how we will do? So firstly we are given, these are the parallel lines. This is given. Okay, and this is the midpoint, D is the midpoint given. So when this line is parallel to this one and this one parallel to this one, that time DMCB means this one quadrilateral is a parallelogram. So we will write from here, firstly construct a side CM parallel to BA and draw or extend. Extend means further draw. Extend line DE to M. Okay, to M. DE extended to M. Okay, so M is the point where they joined lines. Now we can write, this is the proof, DB parallel MC that we have taken right now, we have drawn. So DB parallel MC and DM parallel BC, because DE parallel to BC given. So DM also, when further it is extended, that time also it is parallel to the BC. So that's why DM CB is the parallelogram. If it is a parallelogram, that time DB equal to MC. Okay, because opposite sides are equal na. DB equal to MC and DM equal to BC. Okay, so DB equal to MC, but DB equal to AD given. Okay, DB equal to AD given, because D is the midpoint, that's why it is given this side equal to this much. Okay, but this is also equal to this side, that's why AD and MC also equal. Okay, so from 1 and 2, okay, from 1 and 2, AD equal to MC. Next, now we are taking those triangles, this and this, to prove they are congruent. So we will write in triangle AED and triangle CEM. So in this we are writing this angle 1 and angle 2. Okay, so we will write angle 1 equal to angle 2, vertically opposite. Okay, and then we will write AD equal to MC, that we have proved here. Downside we proved now. This is equation 3. Okay, so we can write from 3. From 3. Okay, and another we will prove any one angle. Okay, and next here you see this angle equal to this angle. Reason is these are the parallel lines. Okay, and DM is the transversal. So we can write now BA parallel CM and DM is a transversal. Okay, that's why angle D equal to angle M. It is interior opposite angles. Okay, hence it is ASA rule, triangle AED congruent triangle CEM. That's why AE equal to CE. Okay, this is proved. That means it is a CPCT. Okay, that means E is the midpoint of side AC. Hence proved.